You can see here just the kind of soldering that's in this thing. The lead goes straight through, hangs past by about 1/4 of an inch, and not adequate solder in the eyelet. Probably couldn't get it to stick to the old corroded tag there, which we'll clean off. No wrap on the lead, that's just asking for trouble, that kind of stuff. So we've got two different schematics here. One of them we don't know the year, 1756. That's the model number. It's not that old. And one of them's 1963 is the year, 1746. So 10 digits off, probably consecutive models. And this one, the earlier one, takes its plate supply. Sorry, I should do this digitally, but I just want to get this done. It takes its plate supply from before the resistor, showing here. Our model has a choke. You can see we've scriggled the choke in there. And this model here takes its plate supply from after the choke. So the only thing on this side of the choke is the bridge rack, and then you've got your center tap for your output transformer after the choke. So this appears to be that model, the 1756 40 watt, because we've got our output from the rectos there. That's this red wire down here. That goes all the way over here to the input of our what appears to be an aftermarket HT fuse. Out of that goes to your first node. That's one of the filter cap sections out of the 100 microfarad cap, or what will be the 100. It's currently 110 and 80, which is weird values. That goes through the choke to your next node. Blue wire there. Followed that over here. That feeds into the center tap there. So that's post choke. Then you got your 33K there, which is indicated right there, and that goes to an 8 microfarad 350, or that's what it used to be. And now you can see with that link wire there, a bit hard to see, there's a bit of bus wire there, and someone's put a 22 microfarad 450 volter in there. If we can find the bloody label, there it is. Hope I'm not making you motion sick. So this is the 1756 model 40 watter. You can also see here the different bias resistor values for the two different models. In the 1756 you're expecting 10K, and the 1760, which is a 60 watt version, you're expecting 6.8K. That is that resistor there with the asterisk after it. Yes, asterisk, not asterix. Not the cartoon from wherever it was from. That's that resistor there, and in the unit itself there it is, and that's a 10K. So this is a 40 watt model. Somewhere else I read, I think maybe online, the different transformer models for the different wattages as well, because that's a thing. Now, aside from that choke and the position of that plate node being different, they're pretty much exactly the same circuit. So it looks like they got the sort of front end sorted and just played with the power supply over the coming years. Probably, well, you'd think cost cutting, but the earlier one didn't have a choke. Maybe availability was an issue, not sure. And the later ones did have a choke, so maybe they were trying to reduce the amount of hum, perhaps. Dunno, mate. It's all just, what's the word? Speculation. It's all just speculation, really. So often the easiest way to remove these caps is to just disconnect them, take all the wires off. Here I've snipped the top of the eyelet to prevent heating the lead too much that the jacket melts, so I can just quickly heat it up, remove the wire, and not melt any wiring. And we've just broken off the base plate, which is just Bakelite, broke rather easily. Because you can't get a drill in there right against the cap body, to drill out that rivet effectively, so this way we can just get it out of the way, drill those rivets out, and put some machine screws in there with some nylock nuts on the new brackets that are going in. And likewise over the other end, we've just broken off that phenolic base. We'll drill those rivets out too and put the new bracket on. Just got a bunch of 12AX7s turn up in the mail. Gonna try some of these out. Everyone else is doing it. I want to fit in with the cool kids and try a piss vane. Who doesn't love a good piss vane? Unfortunate name. Might translate to something in Chinese, I don't know. Maybe we'll never know. We've drilled out the rivets, we've just got to drill some new holes for the bracket. You see it's slightly further apart in centres than the previous cap was, probably by about 1/4 inch total. So we're just going to offset that, drill 2 new holes. If we try and drill where those old ones were, it's going to just fall back into them. We could elongate them, I guess, but save sitting here for half an hour on the file. Just drill 2 new holes offset. They're concealed by the cap anyway, the old ones, more or less. Of course my battery dies because I'm doing a video. Why else would it? Well there we go. So I just had the cabinet up on its side, putting the clamps on for the capacitors, and noticed it says Roller, which is the brand, another Australian brand, 3rd of May 1965. So we know the amp's at least after that, which backs up our estimate that it was the later model. Now just another little detail here. I like to tighten that screw up. Well, these screws, the bracket is, you can see there's about 1 mil under it there. Same on the other one. With the cap hard against the chassis. So we do up this one, clamp it on the cap. And now when we do these ones up, there'll be a little bit of pressure against the chassis. Not much, but just enough that this cap won't rattle against the chassis once the amplifier's in use. There you go. Now she's nice and tight like a tiger. It's the little things that count. So I've redone the fuse. It had the input to the fuse on the outer terminal, which would possibly, if you stick your finger in there with no fuse, or when you pull it out and your fingers sort of go around the fuse itself, could potentially touch high voltage, your fingers. So I've changed the input to the end, where when you pull the fuse out it loses contact with that first, and then the output of the fuse, where there should be no voltage present, is on the outer terminal there. This was already replaced at some point. These are the original wires. This is actually Teflon already, so that's very nice. We've got our new cap in there. Nothing's soldered yet because I'm extending the leads to the choke so they're not singing tight. We've put our little grommet down there, so no threat of cutting through the wires, but the stock PVC wiring to the transformer stops there. We've got 2 splices, and then we've got 2 new bits of Teflon wire, which is nice there. And next time they change the cap, they won't melt the ends of the jackets, but we'll have a little bit more slack on there too. Now there's nothing wrong with doing splices. You got to do them correctly. So on the left there is one that I've soldered. On the right showing one pre-solder. You can see there just a little J, and then just crimp them over with the pliers, and then you're good to solder them. And I generally like to do maybe 1 layer of heat shrink on each one. If you're doing something with 240 volts, I sometimes like to put 2 layers of heat shrink on there, just to be safety Steve. And then we'll connect them up to the cap and we'll move on. So these 2 dropper resistors, they're on, it's kind of a weird circuit, but they form basically the screen supply. And it's supposed to be 180 ohm. These are both 4.7k, so that would lead us to think we've got about 2.35k, 2.4k. We've actually got about 8K. So they've drifted upwards dramatically, and I don't think they're stock just because no other resistor in the amp looks like them, and the fact that they're paralleled instead of getting the correct value means I'm going to replace that with a 180 as per the circuit. We're going to see where that lands us. We can reassess values and stuff later. It's got the 47 ohms there, which might be a bit low. They are old valves, but they could overload the screens a little bit once the plate supply starts sagging. So I'll start with the stock values and we'll see where we're sitting under load and reassess from there. So here I've just unsoldered one end of one of the bias capacitors, and the other end's just dry joint. So that's why you don't want to do just tack joints, tack solder joints. I call tack when there's no bend on the other end. It's just literally the solder going through. If you've got a little bit of corrosion on that lead, this is probably an old cap that they just dug up. You can see the burn marks and stuff from the installation. It's probably got corrosion on the lead and the solder's not wetting to it, even though it looks like it on the surface. So that was possibly our problem, our main problem. All the other stuff was preventative maintenance or improvements, just you know, stuff past its use by date. But that could have been one of the major, it just fell out, one of the major problems too. So being a bass amp, if it's used for bass anyway, there's quite a bit of vibration going on, so you want to mitigate that any way we can. So I think that's the reason for the sketchy wiring in this area. They've snapped off an eyelet and they've just put bus wire all over the place to try and compensate for it. We might replace that with a little tag and just rivet it on. Alright, so we've got a new cap in there. We're going to 10 microfarad, 450 volt. See how that performs. It's on the same node as a phase inverter, which is cathode ion, so we might have to possibly add another node for the preamp stage, like V1. But we'll see how it performs. That might bring the noise down quite a bit without any really tonal differences. I've still got to change film caps out, but we've done a bypass there for V2A and that filter cap there. So next I'm going to divert my attention to this here, which is the bypass cap for the sorry, let me get my head straight there, for V1A. So that's the bass channel, so it's fully bypassed, 25 microfarad. Just it's not real good. It's got twisted wire, it's got tack solder joints, it's got cut off bits of wire that are left on there. It's just a bit messy, so I kind of want to clean that up. And not only that, but the cap itself, it's let's go manual focus for once, it's a little bit melty. Someone's been in there and hit it with the barrel of the soldering iron, so I don't like seeing that on electrolytics because they're not real happy with large amounts of heat. And just from a fit and finish perspective, it looks pretty poor form to leave melted component jackets in an amp. Call me crazy. So again, my OCD got the better on me here, and I redid the whole bias supply except for that 33mm drop. Not really drop, but 33. Bottom half of the divider to ground, that measured fine. And I've put a new, so that 10K there, that's new. I put that in there because that's critical. If that goes open circuit, you lose your supply. Whereas this one, if that goes open circuit, it just goes to most negative supply, so lowest dissipation. We've got two new Nichicons in there, replacing those ones that were standing up on end. They're a lot more securely mounted, just being axial, lower center of gravity, less vibration prone. I've replaced all the bus wire. I've put that new little tag on there with a rivet. You can see under that cap, the caps are slightly above that, so when they heat it up, they didn't melt the can. Blah 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 blah. So we've cleaned all that up. That should be nice and stable now. No adjustment, but if we wanted to, we could make one of these resistors adjustable. We'd probably likely make this 33K here adjustable with an end stop resistor, and that would allow us to have adjustable bias as well. To do that, we might have to change that 10K to a different value to have a better range. What a beautifully executed joint that was. That was wrapped around another lead about 4 times, so that was fun to undo. And they were connected to ground here, which seems to have the cutoff of the previous component left on, and then it was just tack soldered against that. So people often ask, why don't I just get it running and just get it out the door? I try to aim a bit higher than just getting stuff out the door. I want it to be reliable for a long time, and if you leave this stuff in, it won't be reliable. It'll come back, and then they'll have the valid question, why didn't you fix it? And if I just go, because I only fixed what was broke, like a lot of other techs say, they won't come back. They want someone that's thorough. They want to know what status their amp is in, and I'm here to tell them that. Quite happy to. Alright, now that's a little bit better, isn't it? So we can easily access that cap in the future. There's no twisted crap to disassemble after desoldering. You can just desolder that bottom one, desolder the top one. I've carried the resistor lead through to go to that ground point up top, which was pre-existing. And you can change that cap without removing the resistor, which is what we want for future serviceability. One thing I am going to do, definitely, is plug these holes. That was the speaker hole in the middle. That's oversized, so we might have to put a plate or something on that to reliably mount the jack. These holes here are directly above the output valves, so it is like screen voltage there. The plates are on the cap, so this thing's already dangerous enough as it is, but the last thing you want is someone sticking a screwdriver in there thinking, I don't know, it's a bias adjustment or something, and then copping a bit of high tension. It wakes you up for the morning. It's eat that shit for breakfast, but some people, it can stop their ticker. So yeah. Down here I've changed those output coupling caps. Reused them, but I put some heat shrink on there and shortened the leads like to about half of what they were. There's no need to have all that excess length in there that can just get moved around if someone services the thing and like bumps it with a screwdriver and it ends up shorting out. For some reason this one has no markings. I think the tape unwound itself a little bit and the logo is printed just on the outside. On some of the Mallory 150 series, for example, the logo, well, that stamp is continuously printed on the film, so if a little bit unwinds you can still see the next layer, but on this one it's only got one print. I did test this one and it's the same value and it appears identical, and they appear to have been installed at the same point, so I've just reused them. So now all I've got to do is change these cracked film caps that allegedly may still be good, but I don't like having cracks in film caps because moisture ingress makes them fail. So we'll change them out with some Mallory 150s, 150s. Might leave that one there, it looks okay and it's not near the heat and it's doesn't have any voltage on it. But oh, that one's going to be fun to change. Same deal, stuff twisted around stuff, it's just really time consuming. Anyway, let's battle on. Alright champions, so all the work's done. I'm about to fire it up and give it a test. In hindsight, none of these models had a HT fuse, so someone has installed that after the fact. So having a 20 amp fuse in there is basically the same as the stock circuit of not having a fuse at all. But if you're going to put a fuse holder in there, put it, you know, like 500 milliamp would do the job. So that's what I'm putting in. All the caps are done. I think we redid the bias circuit. I think we ran over that earlier. This was fun. With the oversized hole, I filed 2 little half moons into a washer, 10mm washer, or drilled it out to 11mm, and then riveted it, and then put an insulated socket on there. So now we've just removed the ground loop. I want the return current from the speaker output going straight to the transformer, which is where it links up there, but it's still tied to the ground bus. That's the minimum path really for the return current for the speaker possible. So that's what I've done and kept it away from the chassis. That's the bias we talked about earlier. I redid the rectifiers, a little bit neater now. Redid a bunch of the wiring so there wasn't like 50 wires going into one eyelet. So you can see the little link wire in the middle of the rectifiers there. So now that's just got some extra holes for the wires to go in, so they're not all just tack soldered. Everything actually passes through the hole. There you can see the other cap there. Put put a dedicated ground lug with its own screw, not holding onto anything except for that lug, with a lock washer eyelet. Got the new cable installed. That's a safety plug. It's got those plastic bits in there. If a guitar string falls in while the plug's hanging out by a few mil, you won't get shocked. It's got a strain relief gland there, longer earth than everything else. The active goes straight to the fused tip, which is also I've insulated with a bit of heat shrink, and then the neutral goes straight to the transformer winding. So we've given everything a clean. I've cleaned the pots as best we can, and we're just about to give it a fire up and start doing some measurements. Hopefully all is well. Alright, one more tweak. I added adjustable bias. The existing valves performed okay, but they were running at around 130 to 140% dissipation. These are only 15 watt valves. They are otherwise performing fine because they're tough as nails, but we want them to last as long as we can, being 6DQ 6As. They're not the most common valve going around, and if we want to be you know, authentic to this amplifier's design, we want to keep them running as long as we can. So there was enough headroom in the bias supply to add adjustment there, play with the values of the resistors, and get it down to an adjustment range of, well, with this particular set of valves, an adjustment range from 50 to about 70%. Being a fixed bias amp, that's about optimum. And that's about where we're going to leave it now. And that's it for the repair video, part 2. Part 3, just going to be no bullshit, no talking, just straight into riffs. And pretty mediocre ones at that. So I'll see you then, champions. Ooh.